Okay, so what we're looking for is the gradient of these line segments. Now the word gradient, so gradient is another word for slope. Okay, so that's how steep that line is. And the formula to calculate slope is the rise divided by the run. So that formula there is going to be for every single gradient calculation that we do. So you can find the gradient or the slope of any line segment by picking 2 points on that line segment. Okay. So for these ones in question 3, I'm just going to pick the beginning of the line and the end of the line. Now, in reality, it doesn't matter what 2 points you pick, but this will just make it the easiest for us. Now, when you think I'm going from the left point to the right point, you need to essentially count how many units you are rising and then how many units you're running, which means going across. So if I'm doing the rise, I'm going from here up to here. Okay, so remember I'm going from this point to this point. So the rise, if I'm counting the grid lines as my units, we've got 1, 2, 3. And then the run, which is going from here across, is going to be 1, 2, 3 as well. Okay, so basically for 3a, we would do rise over run, which is 3 divided by 3, which is 1. Okay, so the gradient or the slope for this one here is 1. Okay, so this next one, we'll get our 2 points again. So we'll go at the beginning and then at the end. And then rise over run, my rise from here to here is 1 unit. And my run, which is from here to here, is 1, 2, 3, 4 units. Okay. So for this one, I'll do this one in blue. Rise over run is going to be 1 over 4, which we can just leave as 1 over 4. So you can just leave it as a fraction. So slope is 1 over 4. Now this third one, we've got our 2 points. And when we go from the left point to the right point, we're not going up anymore, we're going down. Okay, so our rise is going down, which makes it a negative number. So we've got -1, -2, -3 units. And the run going from here across is 1, 2, 3, 4, 5. So that's 5 units going across. So we'll do that one in purple. The slope, which is rise over run, is going to be -3 over 5. And we can just keep it like that. And we could simplify those fractions if we could, but this one can't be simplified. So it's going to be -3 on 5 is the slope. So for question 4, find the gradient of the following. Now this time you don't even really have, you don't even have to measure anything. It's just essentially given for you. But the challenge here is these numbers aren't necessarily assigned as negative. So if we have our 2 points, and same thing, slope equals rise over run. So for this first one, it has, oops, I lost my mouse cursor. Where is it? Here we go. So the first one, from this point to this point, it says that this side is 3, but if we're going from point A to point B, we're actually going down by 3. So the slope would be -3, okay? So the word rise indicates going up, but because we're going down, we have to say it's -3. And then the run is just going to be 8. So this one here, I'll do in green, is going to be -3 over 8. And that's it. That's the answer. Okay. So for 4a, the slope is -3 over 8. This second one, we've got our 2 points here and here. Now the trick with this one is it's rise over run. And this one here, if we're going from left to right, you kind of have the 15 down there and then the 1 up here. But that doesn't matter. We're going to go up here, which would be a rise of 1, which mirrors that side over there. And then the run going across is going to be our 15. Okay. So the trick for this one, the slope, I'll do it over here, is going to be 1 over 15, not 15 over 1. So our slope is rise 1, run of 15. Last one here, 2 points. Remembering we're going left to right. Okay, so we've got 1, 2. So again, the rise this time, we're decreasing, we're going down. So it's going to be negative 12. And the run going across is going to be 4. So you can kind of see the run always tends to be positive, but the rise, if you go up, it's positive. If you go down, it's negative. So this one here, the rise over the run is going to be negative 12 over 4. Now this one, we can simplify this fraction. So we've got a high common factor of 4. So 4 into 4 goes once, and 4 into 12 goes 3 times. So our simplified fraction is negative 3 over 1, which is negative 3. Okay, so the slope for part C is actually negative 3. All right, over this one here. So question 5, find the gradient of the following lines. So here we've actually got a Cartesian plane, or I guess a part of a Cartesian plane. Now the trick with this one is the 2 points are already given to you, and one of them is the origin. Now the origin always has the coordinates of 0, 0. Okay. Oops. It's always 0, 0. They're the coordinates of the origin. That's supposed to be a comma. And we've got this point here. So basically what we're doing is we're going from the origin going up. So again, we'll just go slope equals rise over run. So for the first one, the rise is from 0 to 3. Okay. Do you remember the x coordinate is the first coordinate. Okay. And the y coordinate is the second coordinate. Now, if you're going up and down, that's on your y-axis. Okay. So you're looking at the y coordinate to start with. Okay. So your knowledge of coordinates is important here. So we're starting at 0 and we're going up to this y coordinate of 6. So the rise is going to be 6. And the run, so that's 6 there. And the run is going from the 0x coordinate to the 3x coordinate. So the difference between that is 3. So that's the run. And then that can be cancelled out to 2 over 1 by dividing both sides by 3, which is 2. So for this one here, our 2 points, so our rise is going to be negative. Okay. So again, we've got 0, 0 for our origin. So for this one, we're going from our 0 y coordinate to our negative 4 y coordinate. So that's a run of negative 4. We're going down 4 units, so it's negative 4. And then going across, we're going from our 0x coordinate to our 2x coordinate, so that's a run of 2. So for this one, I'll do it in green. The slope of rise over run is going to be negative 4 divided by 2, which your highest common factor there's 2. So it's going to be negative 2 over 1, which is negative 2. So that's the slope for the second one. Now this one here, we've got a couple of tips here. A horizontal line has 0 rise, so the gradient is 0. And a vertical line has no run, so it has undefined gradient. So this one is a horizontal line. So a horizontal line going this way is always 0 gradient. Okay. So the slope for that one is going to be 0. You don't have to do any calculations. Okay, that's it. Hopefully that helped a little bit. Thanks for watching.